This is Team Becca's electrical engineering report. I was the team leader. My name is Eliana Montes Haro.
And I'm Audrey Devine. I did the Excel schedule and the PowerPoint presentation.
I'm Colin Vernon, and I am the video recording coordinator.
The amount of sunlight that strikes the Earth's surface in an hour and a half is enough to handle the entire world's energy consumption for a whole year. That's a quote from the Office of Energy Efficiency and Renewable Energy on solar power. So, why aren't we all using it? I think we should. Solar power is made by capturing energy from the sun, and the two major technologies for solar power are photovoltaic and solar thermal. Photovoltaic directly converts sunlight into electricity using panels made of semiconductor cells, and those are the ones that we see on the roofs of buildings and homes. So, solar thermal captures the sun's heat and can be used directly, and this is a low temperature solar thermal. It can also be converted into mechanical energy and then into electricity. So it's concentrated solar power. It's a clean and renewable energy source.
Wind power is made from capturing the wind and turning it into power by using the wind to rotate the blades and generate electricity. And it's very interesting that there are two different types of wind turbines. We have the horizontal axis turbines. These are what many people think of when they hear wind turbines, pictured below. And we also have the vertical axis turbines. These turbines are omnidirectional, meaning that they don't need to be adjusted to point into the wind to operate, and they look like little whisks that you have on like a kitchen mixer. Over the past decade, wind turbine use has increased more than 25% each year. Mass production and technology advances are making turbines cheaper, and many governments offer tax incentives to spur wind energy development. Industry experts predict that if this pace of growth continues, by 2050, one-third of the world's electricity needs will be fulfilled by wind power. Now, what's really cool is that even a small wind farm like the one pictured above can generate electricity to more than 9,000 homes and larger farms. This is said by the U.S. Department of Energy in a video that I used to get some of my resources.
Wave energy is a form of renewable energy that can be harnessed from the motion of waves. There are several methods of harnessing wave energy that involve placing electricity generators on the surface of the ocean. Wave energy produces fewer carbon emissions than energy from traditional fossil fuels such as coal or oil, making it a more eco-friendly option. The theoretical annual energy potential of waves off of the coast of the United States is estimated to be as much as 2.6 trillion kilowatt hours, or the equivalent of about 66% of US electricity generation in 2020. One way to harness wave energy is to bend or focus waves into a narrow channel to increase their size and power and to spin the turbine that generate electricity. Despite decades of research, the motion of the ocean has proved difficult to harness. Wave patterns are unpredictable, seawater corrodes metal generating machinery, and waves energy is simultaneously dispersed across the three dimensions: up, down, forward, backward, and left, right. Geothermal energy is a type of renewable energy taken from the Earth's core. It comes from heat generated during the original formation of the planet and the radioactive decay of materials. This thermal energy is stored in rocks and fluids in the center of the Earth. It has been used in some countries for thousands of years for cooking and in heating systems. The underground geothermal reservoirs of the steam and heated water can be used for electricity generation and other heating and cooling applications.
Dry stream plants use dry steam plants use steam directly from a geothermal reservoir to turn generator turbines. The first geothermal power plant was built in 1904 in Tuscan, Italy, where natural steam erupted from the earth. Flash streams plant plants take high pressure hot water from deep inside the earth and convert it into steam to drive generator turbines. When the steam cools, it condenses to water and is injected back into the ground to be used again. Most geothermal power plants are flash steam plants.
Types of geothermal power plants. Binary cycle power plants transfer the heat from geothermal hot water to another liquid. The heat causes the second liquid to turn to steam, which is used to drive a generator turbine. So there's the dry steam power plants, there's a flash steam power plant, and the binary cycle power plant.